Hi! As promised, we're back to begin part 6. In the last part, we modified the sketches in the box top and bottom to create bosses. These bosses are needed to allow screws to fasten the top to the bottom. This time, we're going to create holes to thread in the bottom. Then we're going to use FreeCAD's hole tool to countersink holes in the top to accept a flathead screw. Finish this and your enclosure is ready to fasten shut. Now that the task is laid before us, let's get started. To begin, we're going to expand the box bottom tree by double-clicking body 001 and then click the top of one of our bosses. Next, we'll create a datum plane atop the bosses in the box bottom. Then we'll create a sketch atop the new datum plane. Since we've done this many times before, I'll simply say that we'll click on the construction icon and create a construction rectangle. We'll then use the symmetry constraint to center the rectangle and use the vertical and horizontal dimension tools to dimension the rectangle per our spreadsheet boss center, width, and height. While we wait for this to complete, I do want to take time to thank all of my channel's new subscribers. I really do appreciate all the likes I've received, but subscribing is the thing that moves me forward toward YouTube funding. Also, it's important after subscribing to hit the notification bell as well. If you don't, you won't be notified when the next part of this series is released. So if you haven't already, please take time to hit that subscribe and notification. I really do appreciate it. Thank you. We'll then click the construction icon to switch back to regular lines. Next, it's time to zoom in to create the circular holes, which will be our holes to thread in our box bottom. We'll then set all the holes to be of equal diameter and dimension one of them according to the screw tap drill diameter. Notice when I select the circle dimension, there is a drop-down menu next to it. I'm going to select circle diameter instead of the default circle radius. Next, we'll use the coincidence constraint tool to fasten the circle centers to the corners of our construction rectangle. Although I haven't mentioned this before, I make extensive use of the point constraint tool to fasten things together instead of just connecting them point to point. And this is because the point constraint tool is a constraint just like the symmetry or dimension constraints. I learned this the hard way by using this approach, that it keeps your sketch from falling apart when you change dimensions in your spreadsheet. The boss center width is boss center width equals width internal notch minus 2 times enclosure boss radius, while boss center height is height internal notch minus 2 times enclosure boss radius. Moving over to the beginning of the sheet, we see that the tap screw dimension is simply screw tap dimension equal to the value we insert in cell B11. It's time to switch back to our drawing, close the sketch, and hide the datum plane. We'll select the notch tool and notch all 4 holes equal to the box bottom depth. Click the OK button in the combo box and return to the model tree. This completes the hole creation for the box bottom. Although similar, the holes for the box top are started on the lid of the top. As an additional twist, we'll use the hole instead of the notch tool to create the countersunk holes. First, we'll switch to bottom view to prepare the top 4 hole layout. Then we'll double-click on the body icon and mount a datum plane atop the box lid, as well as create a sketch on the datum plane. I'm going to time compress the following steps since they are identical to what we did on the box bottom. That said, we'll create a construction rectangle, center, dimension, and create 4 free-floating circles ready to attach to the corners of the rectangle. Rather than dimension the circles first, we'll attach them to the corners of the rectangle. That said, we'll now dimension the upper left circle diameter. You may have noticed that I used the screw clearance diameter. Like the tap diameter, there's nothing special about cell 12B. It simply contains the value for the diameter. We'll now close our sketch, hide our datum plane, and prepare to use the hole tool. Upon selecting the hole tool, you'll notice that the combo view is populated with quite a few options. Do have fun experimenting with these options on your own. To begin, we've selected Profile as None. And this grayed out a number of options which simplified the number of choices. We are left with a hole diameter and hole depth. Again, these are pulled from column 1 of the spreadsheet. Next is our hole cut. First, we'll select countersink. As you can see, we're left with head diameter and countersink angle. Head diameter is simply pulled from column 1 of the sheet. We could also parametrically define the angle as well, but I chose to manually define this. If you live in a metric country, the angle is 90 degrees. Since I live in the US, the angle is 82 degrees. Yes, I know there is also a 100-degree angle, but this is mostly used for fastening sheet metal. Let's set these two dimensions. We're going to zoom into the upper left hole to see what we're now left with. As you can see, we now have a truly countersunk hole. We could just as easily have chosen counterbore for such things as a machine or panhead screw. To demonstrate, we'll change countersink to counterbore. Our options are now diameter and depth. As an option, I did provide head height in column 1 of the spreadsheet. We'll now parametrically set this dimension to the parametric value in the spreadsheet. To better see, we'll change the perspective view slightly. This completes the design of our enclosure. If you've been following along, you could now take your file and run, but there is still one finishing touch we need to do. That touch is filleting both the inside and outside of our box. This will be the final step to complete for this project.